Hello, this is Ashleigh Wright, and I'll be doing question 15 from homework 3, which is all multiple choice. The question reads, suppose that f has a positive derivative for all x values and that f of 1 equals 0, for which the following statements must be true for the function g of x equals the integral of 0 from 0 to x of f of t dt. Give reasons for your answer. So A states that g is differentiable at the function of x. This is true because it's been stated that f must be continuous to be differentiable, and g is differentiable by the fundamental theorem of calculus, which states that taking the derivative of f means that g must also be differentiable. B says that g is continuous for function f, or function of x, and which is also true because in order for something to be differentiable, it has to be continuous as well. The graph of g has a horizontal tangent at x equals 1. This is also true because f of 1 is 0. And the derivative of that integral, because of the fundamental theorem of calculus, would make g prime of 1 0 as well. D says g has a local maximum at x equals 1. So this is not true because the second derivative, derivative, as we already stated, is 0, and g double prime would have to be larger than f of 1, which is g prime. The next question states that g has a local minimum at x equals 1. This is true because since there is a critical value at g prime of 1, and g double prime is greater than 0, along with g f prime, which is g. The graph of g has an inflection point at x equals 1, which is false because it's a positive value, and it does not change sign. G states that the graph of dg dx crosses the x-axis at x equals 1. Because f of 1 is 0 and g prime of 1 is 0, that means that and g of prime equals f of x, that is an increasing function because it crosses the x-axis.